Hey guys, today we're going to do Chapter 8, Section 2. This is another look at particle motion. Net change theorem here, integral from a to b of f prime is f of b minus f of a. You guys have seen that several times. A couple of things you might want to know about displacement, total distance, and actual position. And I will tell you that what we're going to be looking at today is we're pretty guaranteed at some point it's going to be on your AP exam. So displacement, total distance, and actual position. So as we're looking at this graph here, the total distance is going to be found by going from 0 to 10, total distance, 0 to 10, of v of t dt, which is 18 minus 12, which is 6. Total distance, distance is always positive. 18 plus 12 is 30. And the position, where are you? C is your initial condition, tells you that you started at 4. 4 plus your integral from 0 to 10 is 4 plus 6, which is 10. Now we're going to look at the velocity graph that you see here in example number 1. The graph at the right represents the velocity of a particle moving along the x-axis on the interval from 0 to 8, where v of t is measured in inches per second. So for what intervals of time is the particle moving to the right, and justify your answer. So we're looking above the x-axis. So we're looking to see where v of t is greater than 0. The particle moves right on 0 to 3 and 7 to 8. Take a look at that and make sure that makes sense, and try part B. All right, I hope you guys got a chance to look at part B. On what part interval is the particle slowing down? The particle will slow down where v of t and a of t have different signs. So this occurs where the graph is decreasing and above the x-axis from 2 to 3, or increasing and below the x-axis from 6 to 7. Where is the particle stopped and changing directions? Justify your answer. So we're looking for our x-intercepts. And this occurs when time is 3 and time is 7. So remember, that's when v of t is equal to 0. And on what time intervals is the acceleration 0? So that occurs where a of t is equal to 0. That means v of t is constant. And this occurs when time is between 1 and 2 and 4 and 7. You may want to get a piece of notebook paper for this next problem. I'm going to show you how to do a few of them, and then I will just show you the work to complete the table here. So the city bus accelerates as it leaves one stop, and it decelerates as it comes to another stop. The chart below measures the velocity v given in miles per hour excuse me, between each stop. Find the distance in miles the bus travels between every interval stop using the trapezoid rule. So our trapezoid rule is 1/2 height times base 1 plus base 2. So like I said, I'm going to do a couple of these with you, and then I'm just going to quickly show you the work that it would take to find the others, and you can pause your video and grab some notebook paper and make a note of those. So our height is going to be our time interval divided by 60. So we know 0, 0, we know that distance is 0. So for this first box here, when your time is 5 and your velocity is 18, you're going to get 1/2 time interval is 5 times b1 plus b2, so 0 plus 18. Now when you type that into your calculator, you should get 0.75. And for your next box, time is 10 and velocity is 6. you get 1/2 times 5 minutes over 60 times 18 plus 6, and you should get 1. So while you are looking at the notebook paper, here are the rest of your values for your chart. So you may want to pause your video, write those down real quick, and we're going to fill those in on our chart and then answer question B. So 3.166, 1.5, 1.666, 4, 4.25, and 0.9166. So to find our total distance, we're going to just add up our purple numbers, and we get 17.2486 miles. Some motion problems will require you to find the actual position of an object or particle at a given point in time. Remember, you will need to use the initial conditions in order to find an actual position, since the definite integral only provides the change in position of the object. So an object moves in a straight line with a velocity v of t equals the square root of 3t minus 2 meters per second, where time is in seconds. At time equals 5, the object's distance from the starting point was 12 meters in a positive direction. So write an integral expression to compute the object's position at time equals 10 seconds. So we're looking for the initial position plus the amount of displacement that takes place. So it tells you that the starting point was 12 meters plus 10 seconds. So the integral from 5 to 10, because at time equals 5 is in your problem, square root of 3t minus 2 dt. So we're going to do math 9 to find that actual value. 12 plus math 9, 5 to 10, square root 3x minus 2 dx. And you get approximately 34.5088 meters. A particle is moving along the x-axis with velocity v of t measured in meters per second after t seconds with an initial position of s of 0 equals -3. Determine the displacement of the particle on the time interval from 1 to 7 seconds. So from 1 to 7, v of t dt. All right, so we have -1/3 t cubed plus 7/2 t squared minus 10t from 1 to 7. All right, so I'm going to store the 7 in here to find this first set and then subtract the 1 when I plug in. So -1/3 x cubed plus 7/2 x squared minus 10x gives me -77/6 minus, plug in a 1. Actually, I don't need to store that. I'm just going to do -1/3 plus 7/2 minus 10, -41/6. So -77/6 plus 41/6 gives me -6 feet. Sorry about that. All right, total distance. Total distance is going to be positive, so we're going to have to use the absolute value here. But we need to make sure that we understand what's happening on the interval from 1 to 7 of our function. So our function is -t squared plus 7t minus 10. So what we need to look at is to see, does this hit 0 anywhere? So let's take that negative out. Factor and that is equal to 0 at 5 and 2. So what we're going to want to do is realize that those are zeros. And so we need to break up the integrals at those points. And here's what that looks like. So we're going to start at 1 and we're going to end at 2 for our first integral absolute value of v of t dt. And we're going to add to that, starting back at 2 and going to 5, and then going from 5 to 7. So we're going to use Math 9 here. From 1 to 2, absolute value v of t and that value is 11 over 6. And we're going to do Math 9 again. And that's 9 halves. And then Math 9, 5 to 7. And I forgot the absolute value last time. Luckily, it was positive. If it came up negative, I would know that I did not do that part. And math enter is 26 over 3. Add those 3 fractions. And you get 15 feet. Sample number 5. Suppose you are driving in traffic behind a large bus at 66 feet per second. This is 45 miles per hour. When you finally get a chance to pass, you step on the accelerator, giving the car an acceleration of a of t equals 4 over square root of t, where a is measured in feet per second, and t is measured in seconds. How fast are you going 16 seconds later when you have passed the bus? So remember, when you go to accelerate, you're already at 66 feet per second. Remember, we talked about using that initial condition. So this is our acceleration. So to find velocity, because how fast we're going is our velocity, it's the antiderivative of a of t dt. So a of t is going to be 4t to the negative 1/2 power. So the antiderivative of that is going to be plus 1/2 divided by 1/2, so 8 square root of t plus c. C would be our initial condition, so that would be 66. So v of t equals 8 square root of t plus 66. So v of 16 is going to be 8 times 4, 32, 32. So 98 feet per second. How far did you travel? So we're looking for our total distance. Antiderivative from 0 to 16, absolute value of v of t dt. So v of t, 8t to the 1/2 plus 66. Take the antiderivative of that. So 16 thirds t to the 3/2 plus 66t from 0 to 16. We don't have any negatives there, so the absolute value we know will already be positive. So plugging in 16, I get 16 thirds. Let me use parentheses there. I think I'm okay, but I just want to make sure. To the 3/2 power plus 66x. I think I typed in something wrong there. I should get 1024 over 3. And then plugging in 0. Oh, I know what I did. I'm sorry. What I did here was I did my Math 9. So I didn't break down the parts like this. So what I just typed in gave me the actual answer instead of breaking everything up. I wondered why it was giving me the wrong answer. So 1397.3 repeating feet is going to be the answer. I typed it into Math 9 instead of breaking it up into the calculator. So sorry about that. And you're welcome to do that as well. So what is your average velocity for the 16-second interval? Is displacement divided by time. So that number we just found, divided by our time of 16, gives me 87.333 feet per second. You drop your calculus book from a window 48 feet above the ground. How long will it take your book to reach the ground? All right, so our velocity of 0 is 0. We're going to call that c sub 1. Velocity of 0 is 0 because I'm still holding the book at time 0. My acceleration using that information from way back is going to be the constant negative 32. So s of 0 is going to be 48, and we're going to call that c sub 2. So I've got velocity, acceleration, and position. So velocity is going to equal the antiderivative of acceleration, which is negative 32 d of t. So v of t is going to be negative 32t plus c. Position, s of t, is going to be the antiderivative of velocity. So s of t is negative 16t squared plus c sub 2. So my position function is negative 16t squared plus 48. So how long will it take your book to reach the ground? When does s of t equal 0? So set that equal to 0 and solve. T squared equals 3. So t is the square root of 3 seconds. What is the velocity of the book at this time? So velocity of the square root of 3. Here's velocity. So we have negative 32 square root of 3, which is approximately negative 55.426 feet per second. Remember that c is going to be 0. A particle moves along the x-axis so that its velocity at time t, for time between 0 and 15 seconds, is given by a differentiable function v, whose graph is shown below. At time t equals 0, the particle is at x equals 4. So there's my initial condition. The velocity is 0 at time equals 3, 9, and 13. The graph has horizontal tangents at 6 and 11. And the areas of the region bounded by the axis and the graph of V are 0 to 3, area of 6, 3 to 9, area of negative 9, 9 to 13, which is 3, and 13 to 15, which is negative 2. So for time between 0 and 15, find the time and position of the particle when the particle is farthest to the right. All right, so we're going to find x of 3, which is our initial condition, plus integral from 0 to 3 of v of t dt. That's 4 plus 6, which is 10. Then I'm going to find x of 13. I've got these are right, so these are above. 4 plus integral from 0 to 13 of v of t dt is 4 plus 6 minus 9 plus 3, and that's 4. So v of t is greater than 0 on 0 to 3 and 9 to 13. So that indicates it's moving to the right because they're positive. So the particle is farthest right at your largest value, which is 10, which occurs at t equals 3. Seems very strange, but remember you're looking at a velocity graph. For how many values of t, where 0 is less than or equal to t is less than or equal to 15, is the particle at x equals 4, and explain your reasoning. All right, so let's talk about the particle and its continuity. The particle is continuous from 4 to 3. Sorry, from 0 to 3. And 0 is at 4. So 0 to 3 on x of 0 equals 4 to x of 3 equals, we found that in the last one, 10. Okay, so there's one x equals 4. X of 0 equals 4. All right, so we've gone from 0 to 3. Now let's go from 3 to 9. So x of 9 is going to be 4 plus 6 minus 9, which is 1. And then let's do 13. X of 13 is 4 plus 6 minus 9 plus 3, and that's 4. So there's another 4. So x of 3 equals 10 to x of 9 equals 1. It's still continuous there. I just don't have a 4. It is also continuous on x of 9 equals 1 to x of 13 equals 4. There's another 4. And then let's do x of 15 is 4 plus 6 minus 9 plus 3 minus 2 is 2. So it's also continuous on x of 13 equals 4 to x of 15 equals 2. So our graph is showing our continuity. What I'm doing here is finding the values where t is equal to 4. So we've got 1, 2, 3 different places where the particle is continuous and x of t is equal to 4. And we know that one of those is the same, but they're on different intervals, which allows us to write it and allow for another value to occur. On what interval or intervals is the speed of the particle increasing, and give a reason for your answer? All right, so the speed of the particle is increasing on 9 to 11 since v is greater than 0 and velocity is increasing. On 3 to 6 and 13 to 15, velocity is decreasing and v is less than 0. So during what time intervals, if any, is the acceleration positive? On 6 to 11, since velocity is also increasing. So remember, increasing in positive or decreasing in negative this happens on 6 to 11. All right, guys, this concludes another look at particle motion, chapter 8, section 2. Let me know if you have any questions. I hope you have a great day.